medicine and biology. And as a group, we apply mathematical modeling techniques to understand biology, understand disease. And I personally am very interested in understanding the mechanisms underlying asthma. It's a massive problem in the sense of the complexity of the biology and also in terms of the different types of asthma that people have. There's the issue of how the airways themselves constrict during an asthma attack. But then there's also the sort of issue where after you've had lots of these attacks, you can get thickening of the actual airway wall, and that thickening can make it even harder for you to breathe if you have asthma. So there's all these different aspects that we're kind of interested in understanding. It is so prevalent. So many people have it. If you ask anybody on the street, do you know somebody has asthma? Most people tend to say yes. It's in terms of fatalities, it's not as massive as cardiovascular disease, but there are still fatalities, and often of young children. The sort of things that are available for relieving asthma symptoms are just that. They're a sort of a band-aid on an underlying problem. You can only relieve some bronchoconstriction when you're actually having trouble breathing, but there is still no real cure. You live with the condition for your whole life, basically. And for that reason, there is a real a need to come up with something that'll be a cure that eradicate it completely. So there's a real challenge there, and so that's kind of how I ended up getting interested in it. I personally suffer from asthma, very mild asthma myself. So that's how I got into it, really. But one of the things that's really difficult is to understand the biology and all the very complex interactions that are going on inside your body. You almost need something that's able to quantify those interactions, and underlying all of those interactions is a kind of physics. You've got molecules interacting, there are forces acting, stresses and strains as you stretch airways. All of these things are physical processes, and they affect the biology affects those processes. So just like we use maths and physics to understand and to design airflow over motor cars or over planes and so on, similarly the physics underlying the biology can be described using mathematics. And without the mathematics, actually, it's very, very hard to come up with an understanding of how the different things interact. You can't do it all in your brain. You need some way of describing that in a quantitative way, and that's where maths comes in.